Welcome back to our board exam review for Fisheries Professionals. Our topic for today is about aquatic resources and ecology. Please hit like and share this video to those people who have not yet taken the board exam. And also please click the subscribe button and notification bell so that you will be informed every time I will upload a new video. Okay? So let's get started. The ability of organisms to succeed under a variety of environmental conditions. A. Range of tolerance. B. Longevity. C. Hardiness. D. Genetic strength. Again, the ability of organisms to succeed under a variety of environmental conditions. A. Range of tolerance. B. Longevity. C. Hardiness. D. Genetic strength. Answer is letter A, range of tolerance. Tolerance, ito yung abilidad ng hayop na mabuhay pag na-expose sa abiotic or biotic factors. Abiotic factors, these refer to the non-living things, while biotic factors refer to the living things. So, example ng abiotic factor is temperature and salinity, while example ng biotic factor naman ay yung mga pathogens. So, we have here an example sa illustration, the tolerance of steelhead trout in terms of temperature. So, dito nakikita na ang range of tolerance ng isda based on temperature is from 9 degrees Celsius up to 25 degrees Celsius. Ibig sabihin, ito lang yung temperature kung saan kayang mabuhay ng isda. So, meron po tayong upper limit na tinatawag at lower limit. So, yung sa upper limit na yon kaya niya pang mabuhay, subalit, nakakaranas na yung isda ng physiological stress. Ganon din sa lower limit. Pag yung temperature ng tubig ay lumagpas sa 25 degrees Celsius, ibig sabihin masyadong mainit na yon para sa steelhead trout. At kung mababa naman sa 9 degrees Celsius, masyado nang malamig yung tubig para sa steelhead trout na mabuhay. So, yun po ang range of tolerance. Example, another example ay sa corals. So, dito nakikita sa example na yung tolerance ng corals in terms of temperature is from 18 degrees Celsius to 29 degrees Celsius. Pag tumaas pa yung temperature ng dagat sa 29 degrees Celsius or bumaba sa 18 degrees Celsius, ibig sabihin hindi na kakayanin ng corals. So, yun po yung range of tolerance ng corals based on the illustration. Next question. Fishing activity that affects the reefs. A. Muroami. B. Pot fishing. C. Blast fishing. D. All of the above. Again, fishing activity that affects the reefs. A. Muroami. B. Pot fishing. C. Blast fishing. D. All of the above. The correct answer is letter D, all of the above. So, examples ng destructive fishing practices are dynamite fishing or also called blast fishing. Tinawag siyang blast fishing dahil sa mga paputok or explosives. Spear fishing is also considered a destructive fishing practice. Beach seining, trap or pot fishing and also poisoning. So, yung effects ng dynamites, of course, and other explosive fishing methods ay nasisira niya yung mga breeding site at yung mga coral reef area. It can destroy up to 10 to 20 square meters sa ilalim. So, effects naman ng trap fishing or pot fishing is, although hindi siya ganun talaga ka-destructive para sa corals, but yung proseso ng pag-set up ng traps, yun yung nakakasira sa mga corals. So, yung trap fishing or pot fishing, usually ito ay ginagamit panghuli or pang-trap ng mga crustaceans. Example, yung crabs at saka lobsters. And effects of muroami fishing, ayan, so sa muroami ay gumagamit ng malalaking bato na pamukpok sa mga corals para takutin yung isda at para lumabas yung isda sa coral at huhulihin nila gamit ang net. Okay, next question. Blank competition occurs between organisms of the same species. A. Interspecific competition. B. Intraspecific competition. C. Mutualism. D. Commensalism. Again, blank competition occurs between organisms of the same species. A. Interspecific. B. Intraspecific. C. Mutualism. D. Commensalism. The correct answer is letter B, intraspecific. So this is a comparison between interspecific versus intraspecific competition. Interspecific competition is usually competition for food and other resources between organisms of two or more species, while intraspecific competition for food and other requirements between organisms that belong to the same species. So, number of species involved pag sinabing inter, two or more. Pag intra, isang species lang yon. So, ano ba yung reason kung bakit merong competition? Example is competition sa food, sa pagkain, at saka competition sa space or lugar. So, andito meron tayong examples ng mga species that may cause interspecific competition. We have here jaguar, yung knifefish, janitor fish, yung tilapiang gloria, and the giantized snakehead. These are all examples of invasive species. Invasive species may cause interspecific competition because they are very prolific and they can reproduce at a high rate, and they can kaya nilang dumami at agawin, kumbaga, yung lugar kung saan doon namumuhay yung mga other fish species. So, because of that, meron tayong tinatawag na interspecific competition. Magko-compete sila sa pagkain if pareho yung kinakain nila, at magko-compete din sila sa space. Zonation of a stream. A. Reaches. B. Riffle and pools. C. A and B. D. No answer. Again, zonation of a stream. A. Reaches. B. Riffle and pools. C. A and B. D. No answer. The correct answer is letter C. A and B. So, reaches and riffle and pools are zonation of a stream or a river. So, what is a reach? A reach is a section of a stream or river along which similar hydrologic conditions exist, such as discharge, depth, area, and slope. Ibig sabihin, meron siyang similar na mga condition. Pareho yung lalim, pareho yung lawak, pareho yung slope. It can also be the length of a stream or river with varying condition between two stream gauges, or a length of river for which the characteristics are well described by readings at a single stream gauge. So, example ng stream gauge, you can see here at the upper right corner, ito yung parang stick na nilalagay sa river or sa stream that will tell you how deep is the water. Okay, so pwede din siyang varying condition, but it is the length between two stream gauges. So in practical use, or in practical term, yung reach is just any length of a stream or river. The term is often used by hydrologists when they are referring to a small section of a stream or river rather than its entire length. So if you are referring to a small section lang, hindi naman yung buong river yung gusto mong i-describe, yung lang, isang section, so you can say, you can denote it as reach. Okay, so what are riffles and pools? So there are actually types of riffles and pools. You have low gradient riffles, rapids and cascades, and pools, the secondary channel pools, backwater pools, trench pools, plunge pools, lateral scour pools, and dammed pools. Dammed ang hirap naman i-pronounce. And also, meron ding glides. So, aside from the reach, riffle, and pools, meron ding glides. Glides, a third general habitat category consisting of moderately shallow reaches with even flow that lack obstructions or pronounced turbulence. So, isa-isahin natin. So, yung riffle is meron siyang moderate current velocity and turbulence. Ibig sabihin, medyo mabilis yung agos ng tubig. At yung substrate niya is composed of gravel, pebble, and cobble-sized particles. Medyo malalaking bato. Yung pools naman, often, for example, the secondary channel pools, often temporary pools remaining in areas flooded by freshets, often associated with gravel bars, sand, or silt substrate. So, at this point sa pools, hindi na siya larger boulders, but meron na siyang halong sand and silt. So, take note that we have different types of pools, and yung sa glide, binasa ko na kanina, yung kanyang flow ng water is not as turbulent compared to the riffle, and yung sa glides is hindi siya ganun kalalim, medyo shallow lang. Okay? And the bottom is also usually gravel and small cobbles. Mas maliit kaysa sa riffle. So, para mas maintindihan natin ng mabuti, we have here an illustration that will show you the difference between riffle, pool, and glide. And actually, meron pang tinatawag na run. Okay? So, ano ba yung riffle? Riffle or rapids. If you can see sa ngayon, uso yung rapids, yung nakasakay ka sa salbabida, tapos, parang adventure kasi malakas yung agos at saka nabubunggo ka sa mga bato-bato. So, yung part na yun sa river or sa stream, yun ang tinatawag na riffle or rapid. Okay, dito naman sa run or glide, ayan, medyo dire-diretso yung takbo ng tubig. At dito naman sa pool, meron siyang slope. So, medyo humina na yung agos ng tubig. Parang meron ka ng swimming pool, and then you have the glide. So, titingnan mo yung glide, hindi siya ganon ka lalim. Yung glide ay shallow area lang. Next, organisms that have eat animals that have eaten plants. A. Primary consumers. B. Secondary consumers. C. Cannibal. D. Carnivore. Again, organisms that eat animals that have eaten plants. A. Primary consumers. B. Secondary consumers. C. Cannibal. D. Carnivore. The correct answer is letter B. Secondary consumers. So, secondary consumers, ito yung tawag sa mga hayop na kumain ng hayop, na yung kinain niyang hayop ay kumain ng halaman. Ayan. So, meron tayo ditong food chain. So, yung grass or yung damo, yun yung producer. And then, yung kumain sa damo, yun yung grasshopper. Siya yung primary consumer. So, yung kumain na hayop sa hayop na kumain ng damo, yung tawag sa kanya ay secondary consumer. We also have tertiary consumer and apex predator. Pag sinabing apex predator, ito na yung hayop kung saan wala nang kakain sa kanyang hayop. Kumbaga siya na yung sa pinakatuktok. So, yung kanyang kapalaran, mamamatay na lang siya. Kakainin. I-decompose siya. Ayan. So, meron din tayong food chain from to represent the aquatic food chain. So, primary producers natin ay yung phytoplankton. Primary consumers, yung kumakain sa primary producers, ay zooplankton. And we have the secondary consumers, yung kakain sa zooplankton, mga maliliit na isda. And you have tertiary consumers, mas malaking isda. And the quaternary consumers, or kung wala nakakain sa kanya, tawag sa kanya apex predator. Ayan. So, if we can observe, na-arrange din siya based sa size. Okay? But, not always, pero mostly, food chains are arranged from yung smallest size papunta sa pinakamalaking size. Salinity could be measured by A. Refractometer. B. Salinometer, C. A and B, D. No answer. Again, salinity could be measured by A. Refractometer, B. Salinometer, C. A and B, D. No answer. The correct answer is letter C, A and B. So refractometer and salinometer are both used to measure salinity. So we have here an example of a refractometer. It is called refractometer because it is based on refractive indices or based on the refraction of light. So when light enters a liquid, it changes direction. This is called refraction. Refractometers measure the degree to which the light changes direction, called the angle of refraction. Solutions have different refractive indices depending on their concentration in water. That's why you can measure the concentration of salt in water, because different salt concentration would result to different refractive indices. So here in the example, the salinity of the water is at 35 ppt. And this is an example of a salinometer. A salinometer is a machine that is capable of measuring the table salt content, known as salinity, of a solution. Another name for a salinometer is a conductivity meter, as dissolved salt in water will increase its ability to conduct electricity at measurable levels. So yung salinometer, it is based on the conductivity of the solution. That means the greater the salt concentration, okay, so the stronger it is to conduct electricity. Okay, so a salinometer generally works by passing an electric current through any known mass of water. Since salt water conducts electricity much more easily than pure water, the salinity content of water can be easily calculated. But usually in ponds and in cages or in our research activities, we use refractometer most often compared to salinometer, because refractometer is easy to use and portable, while salinometer, this is usually used by big research vessels or yun, mga bigger vessels. A fish monitoring method using line transects, 3 by 50 transects, with fish assessed in a column 5 meter wide and 5 meter high above the line. A fish monitoring method using line transects, 3 by 50 transects, with fish assessed in a column 5 meter wide and 5 meter high above the line, or less if the water is turbid. A. Video transect, B. Manta tow, C. Live fish census, D. Permanent quadrat. Again, a fish monitoring method using line transects, 3 by 50 transects, with fish assessed in a column 5 meter wide and 5 meter high above the line, or maybe less than 5 meter if the water is turbid. A. Video transect, B. Manta tow, C. Live fish census, D. Permanent quadrat. Answer is letter C, live fish census. So we have here examples of yung sa video transect as well as the quadrat. So in video transect, of course, you have a transect line that will denote the length, and also you have the camera to capture videos. And sa quadrat, you have this parang square, hindi siya parang square, talaga siya, okay, na meron siyang grids. So this square can be of 1 by 1 meter or 0.5 by 0.5 meter, and this is usually used when you assess corals and seagrasses. Ang manta tow naman usually is merong scuba divers behind a boat or sa likod ng bangka, and the diver maneuvers a tow board connected to the boat by a bridle and tow line and outfitted with survey equipment including digital still or video cameras. So yung scuba diver natin, meron siya nilang video camera or meron siyang dalang board and pen. So, yung scuba diver ay makakapag-record. Okay? Next is, ayan. So, example ng ating live fish census is belt transect. So, it is a visual census of fish. And it is yung live visual census, meron siyang iba't ibang methods. It is the most common quantitative and qualitative sampling method used in fish stock assessment. Okay, so we have an example, the belt transect conducted during daylight hours along three of the same transects as the line intercept, but the fish census transects must be 15-meter long at depths, at two depths, 3 to 5 meter and 8 to 10 meter. So, usually yung depth na yun ay depende kung gaano kalinaw yung tubig. Seagrass classification based on degree and alteration and general community response to habitat conditions. A. Pristine, B. Disturbed, C. Altered, D. Emergent, E. All of the above. Seagrass classification based on degree and alteration and general community response to habitat conditions. A. Pristine, B. Disturbed, C. Altered, D. Emergent, E. All of the above. Answer, letter E, all of the above. So pristine, disturbed, altered, and emergent are examples of seagrass classification. So pristine seagrass meadows, those with high or low diversity of species bordering land masses far removed from human habitations. Disturbed only by the normal intensity of natural elements. Ibig sabihin, pag sinabing pristine yung seagrass, malayo siya sa human interventions, malayo sa komodidad. Yung nagdi-disturb lang sa kanya ay natural elements. The disturbed seagrass meadows, those of high or low diversity beds occupying bays and coves near human habitation. So, disturbed ay malapit sa komunidad or sa human habitation, and merong constant disturbance from human activities. Altered seagrass meadows, those areas of low species diversity permanently and completely changed or converted to other coastal uses like salinas and fish or shrimp ponds. So, sa altered seagrass meadows, konti na lang yung species na nakikita doon. Hindi siya as diverse compared to the disturbed and pristine. Let's say, 1 to 2 species lang. And although it is completely changed, it has the potential to be converted back into seagrass areas through hydrographic engineering, massive transplantation, and rehabilitation. So, sirang-sira na yung altered seagrass meadows because of interventions or activities. And emergent seagrass meadows, those of low species diversity, largely controlled by extreme physical-chemical conditions. Rupia maritima and estuarine spoongrass, which form extensive growths in almost freshwater or in brackish-water habitats, belong to this category. In some parts, freshwater and terrestrial macrophytes and herbs may coexist with the seagrasses. So, yung list na diversity, makikita mo sa emergent seagrass meadows. Yung parang, nasya ka lang, ay, meron palang seagrass dito. So, nag-emerge siya, okay? So, controlled siya by extreme physical-chemical conditions. Ibig sabihin, it is not usual to find seagrass in that area. But, meron kang nakitang seagrass because kaya niyang mag-thrive, although by that physical-chemical conditions. But, konti lang yung diversity because not all seagrass can survive into that extreme physical-chemical conditions. Okay? A category of estuary. A. Highly stratified or salt wedge estuary. B. Partially mixed or moderately stratified estuary. C. Completely mixed or vertically homogeneous estuary. D. All of the above. E. None of the above. Again, a category of estuary. A. Highly stratified or salt wedge estuary. B. Partially mixed or moderately stratified estuary. C. Completely mixed or vertically homogeneous estuary. D. All of the above. E. None of the above. Answer is D, all of the above. So all of these are categories of estuary. So less dense freshwater from rivers flow over higher density seawater, and the water masses will mix at their boundaries. So we know that estuary, ito yung area where the freshwater and the seawater mixes. So ibig sabihin dito, yung freshwater ay less dense. Kumbaga, mas magaan siya kumpara sa seawater. So, yung seawater ay mas mabigat. So, depending on the volume of seawater na pumapasok sa estuary or yung volume ng freshwater papunta sa dagat, so, merong difference ng mixing at saka ng circulation of water. So, we have the vertically mixed, slightly stratified, highly stratified, and salt wedge. So, what is the implication of this? So, meron tayong difference ng salinities because of the different mixing of water. Okay? Blank are produced by the gravitational pull of the moon and sun. A. Tides, B. Typhoon, C. Tornado, D. Night and day. Blank are produced by the gravitational pull of the moon and sun. A. Tides, B. Typhoon, C. Tornado, D. Night and day. Answer A. Tides. So tides are produced by the gravitational pull of the moon and sun. This is an illustration of how tides are produced. So, para siyang lastiko na hinihila, kumbaga yung tubig ay naa-attract ng gravitational pull ng sun at saka ng moon. Pag nahihila siya malapit sa sun and moon, so you have high tide, at saka yung malayo naman sa sun and moon, you have low tide. So, we have here two types of tide, the spring tide and neap tide. Spring tide with greatest difference between low and high tide. Gravity of sun and moon pull in the same direction, occur at new moon and full moon. Take note. Neap tide with least difference between low and high tide. Moon is at the right angle of the sun. Please look at the illustration below. And it occur at the first quarter and last quarter moon. Tides that occur twice daily and are about of equal height. A. Diurnal tides, B. Semi-diurnal tides, C. Neap tides, D. Tidal wave. Again, tides that occur twice daily and are about of equal height. A. Diurnal tides, B. Semi-diurnal tides, C. Neap tides, D. Tidal wave. Answer B. Semi-diurnal tides. So we have here illustrations of different tidal patterns, the semi-diurnal, mixed tide, and diurnal. So if there is one high and one low tide in each lunar day, it is called a diurnal. And dito siya sa pinaka-bottom na illustration. So you have there tidal day and tidal period, merong one high and one low. Sa semi-diurnal naman, and dito sa pinakataas, meron siyang two high tides and two low tides of about the same height daily. So napapaloob dyan sa tidal day, meron kang two high tides and two low tides. So if those two high tides and two low tides are not of the same height, it is called a mixed tide. Blank are single-celled or colonial algae with diffused chlorophyll, not concentrated into chromatoplasts, masked by blue-green pigment. A. Bacteria, B. Blue-green algae, C. Diatoms, D. Green algae. Again, blank are single-celled or colonial algae with diffused chlorophyll, not concentrated into chromatoplasts, masked by blue-green pigment. A. Bacteria, B. Blue-green algae, C. Diatoms, D. Green algae. Answer is letter B, blue-green algae. So, sa tanong pa lang, nakasulat na blue-green pigment. So maiisip natin na, sige, yung tamang sagot siguro, blue-green algae kasi nasa question blue-green pigment. Okay, so ano ba yung blue-green algae? Ayan, we have here a difference between blue-green algae versus green algae. Blue-green algae are a group of bacteria that can photosynthesize. So, the same with green algae. But blue-green algae are prokaryotes while green algae are eukaryotes. Ibig sabihin, yung blue-green algae, they do not have membrane-bound organelles. Look at the photo at the lower right. Meron ka ditong drawing ng cell at saka yung mga laman ng cell ay hindi siya napapaloob sa membranous organelle. So parang andun lang sila lahat sa cytoplasm. Okay, so yun yung mga prokaryotes, no membrane-bound organelles. In other words, wala silang chloroplasts. While yung green algae merong chloroplast. Kasi yung chloroplast, ito yung example ng membrane-bound organelle. So, hindi siya nakikita sa blue-green algae dahil nga yung blue-green algae ay example ng prokaryotes. So, examples ng blue-green algae are Microcystis, Anabena, Nostoc, Oscillatoria, Tolipothrix, and Spirulina. Example of green algae, Chlamydomonas, Chlorella, Pediastrum, Netrium, Acetabularia, Ulva, and Spirogyra. So, blue-green algae or yung algal bloom caused by blue-green algae can be toxic because it releases toxic substances that can affect human health. While green algae, pag nag-bloom, it is non-toxic. The depth at which photosynthesis just balances respiration is called blank. A. Compensation level, B. Thermocline, C. Halocline, D. None of the above. The depth at which photosynthesis just balances respiration is called blank. A. Compensation level, B. Thermocline, C. Halocline, D. None of the above. Answer is letter A. Compensation level. So, compensation depth is the depth at which rate of photosynthesis equals the rate of respiration. So, here you can see in the illustration, imagine ito yung dagat. So, above that, you have the depth where phytoplankton make enough food. Why? Because sunlight can still penetrate that area. But below that depth, phytoplankton starve. In that case, konti na lang yung light na nakaka-penetrate sa area na yon until sa wala na talagang light. So, you have here photosynthesis inhibited here because of too much light, and then at few meters below, depth of greatest productivity, and then lower light levels restrict photosynthesis down here. So, below the bottom of euphotic zone, pa-restrict yung photosynthetic activity because of the absence of light. Pakunti na lang ng pakunti yung light penetration. Below the euphotic zone, you have the dysphotic zone. And below the dysphotic zone, yung wala na talagang light, yun yung tinatawag na aphotic zone. Euphotic zone, yung may light. Dysphotic, konti na lang yung light. Aphotic, wala na talagang light. So, thank you very much for watching this video, and please subscribe to this video if you haven't subscribed yet. So, see you on our next review. Bye!